All right, good morning. So what I would like you to do with this particular video is first, and you'll see obviously two answers already on the screen. First, I want you to check those two answers, okay? If you feel like if you got them right and you feel comfortable with how you got them, then obviously you can skip through till you see the answers to the next two problems. Like fast forward through the video. Otherwise, you'll want to watch and see how I got the answers. I'm going to try to go as quickly as possible just to speed the process up here, okay? So in number one, it's already equal to 0. So remember, you want to look for the GCF first, and that is 3x squared. And so when you divide your pieces by 3 and take out x squared, you're left with 4x minus 1. You cannot factor that more, so you are ready to set both of your factors equal to 0, and now you have to solve them. So for the first one here, we're going to have to divide by 3. We still get 0, and then when we take the square root of 0 is 0. There's no plus and minus when you take the square root of 0, because there's no such thing as positive 0 versus negative 0. For the second one, you're going to add 1 and divide by 4, and you get 1/4, and those are, in fact, my two answers. Okay? All right, in number 2, that one is also already equal to 0, and I see an x to the 4th with 2 terms, so I am checking for dots, and it is, in fact, dots, so I'm going to unfoil. I need to take the square root of 9 and cut the exponent in half, and then take the square root of 16. So I'm going to have the same values in each, but they need to be conjugates. So I have 1 plus and 1 minus. Then I notice that neither one of them, even though I have squares, neither one of them are dots again. So it is now time to set each one equal to 0 and solve. So for this first one here, I can actually, okay, so I don't have my answers matched up at the bottom. That's okay. We're going to minus 4, and we're going to divide by 3, and then we have to take the square root, okay? So please remember that when you take the square root of a fraction, you're taking the square root of the top and the bottom. All right, and then I'm actually going to run out of room here, so I'm going to go over here. So I get x equals plus and minus. Now, the top is a nice square root, but it's a negative, so we're going to take out a 2i. But the bottom is still the square root of 3. And then remember, you can't leave a square root on the bottom, so you're going to rationalize the denominator by multiplying by the square root of 3 over the square root of 3. And then that's going to give you plus and minus. 2i square root of 3, but I just moved the i to the end. All right, and so that's how I got this answer. You do not have to move the I to the end. You can leave it in the middle if you want, okay? And then when I solve the second one, all right, so again, I added 4 and divided by 3 and ended up taking the square root of a similar fraction. It just wasn't negative. And so I should get the same two answers, except it doesn't have an I. And again, I do have to rationalize the denominator. And so that is how I got my final answer of positive and negative 2 square root of 3 over 3. Okay? So again, I had them out of order in terms of how I solved them on the paper, but you still should get 4 answers. 2 have an I and 2 do not. Okay? All right, so I'm going to slide it down so you can see the answers to the next 2 problems. And again, if you got them right, you can skip forward. Otherwise, you'll want to listen up. Okay? So number 3 is different because it is not equal to 0. So the first thing I need to do is make it equal to 0. Okay? And then I can look for my GCF because I need to factor. Well, these only have an x squared in common. So when I take that out, all right, I am left with another binomial that has squares in it, but they're not all perfect squares. So unfortunately, this is not a dots, which means I am ready to set each piece equal to 0. All right, And so then for the first one here, I'm going to take the square root. And remember, when you square root 0, you do not need a plus and a minus. All right, and then for the second one, I'm going to add 9 and divide by 2. And then I'm going to take the square root. Again, taking the square root of a fraction is the same thing as square root the top and the bottom separately. Kind of running out of space, I'm going to go over here. You need your plus and your minus. And when you take the square root of 9, you get 3, but you cannot take the square root of 2. Okay? Well, you can't leave the square root of 2 on the bottom either, so you have to rationalize the denominator. Okay? And you cannot put the 3 and the square root of 2 together in terms of getting a 6, so you leave them side by side, and then the square roots on the bottom disappear, and that's how I got that answer. So I have a total of 3 answers. Remember, we talked about because it had an x to the 4th, you could potentially have gotten up to 4. Okay? All right, number 4 is already equal to 0 for you, but I hope that you were able to notice that since I have a cube right here, and it's only 2 terms, this is a, and there's no GCF, this is the difference of cubes, so this does factor into a binomial and a trinomial. All right, remember your sign pattern is same as, oh no, what did I do? What did I do? Where are my pages? Hold on a second, I'm on. Okay, sorry, I thought I lost it there for a second. Actually, I think I did delete it and I didn't mean to. Okay, so remember for cubes, the sign pattern is same as the original binomial. Come on, there we go. And then opposite of that, why is this being weird? And then plus at the end. So then you go back and you fill in your binomial by taking basically you're taking the cube root of each of these pieces here to figure out where they came from. So the cube root of 8 is 2, and for exponents you just divide by 3, and then the cube root of 125 is 5. And then once you have that binomial, you use it to get your trinomial. So you square the first, the number and the letter, you multiply the 2 together, and then you square the last and put it last. Okay, and then you need to remember that you will never be able to factor that trinomial more, so you are ready to solve. Okay, so remember, solving means you set each one equal to 0. Okay, and then in this one, we're going to add 5 and divide by 2, and that one's done. But for the other one, you're going to have to use the quadratic formula. You absolutely have to. So we have x equals negative of the b value plus and minus the square root of the b value squared minus 4 times the a value times the c value all over 2 times the a value. Okay, I'm starting to run out of room here. All right, so when you simplify the discriminant, that's the stuff under the square root. In this case, you get negative 300. Okay, and so then remember, you need to simplify your radical, all right, by breaking it down. Now, I'm going to take a shortcut. I know that 100 is a perfect square, so I already have my pair of 10s. All right, now you're welcome to keep going and get 2 pair of, or you're going to get a pair of 2s and a pair of 5s. Either way, you're going to be able to take out a 10. All right, and then we're going to come back. We're going to say, okay, get negative 10 plus or minus. We're going to take out a 10, but it was negative, so we're going to take out a 9. We still have a 3 left over, and on the bottom we have an 8. Now, you'll notice that that does not match the answer yet, because you have to remember that if the 3 numbers not under the radical, has to be all 3 places, but not the radical, they have something in common you need to reduce. And so I can reduce all of them by 2, and that's how I got my final answer here. Okay? So remember, when you use the quadratic formula, that does represent 2 answers because of the plus and the minus. And so then we have a total of 3. Okay? All right. And then go ahead and check your answers for 5 and 6. Again, if you got them all right, then you'll want to skip through and fast forward through the video to see the next ones. All right, but I am going to work them. So in number 5, you do need to make it equal to 0 first. All right, and then you'll want to look for a GCF, and you can actually take out a 3x. And then I notice I have an x cubed in my binomial, so I look to see if the other numbers are cubes, and they are. So this is a cube problem in terms of factoring the sum of the difference of cubes. You need a binomial and a trinomial. So 27 comes from 3, same opposite plus, let me get that in here. All right, 27, the cube root of 27 is 3, and then the exponent gives me a single x when I divide by 3, and the cube root of 1 is 1. Then I'm going to square the 3 and the x, multiply the 3x by the 1, and square the 1. Okay? And remember, that's it on factoring. So now you're ready to set each factor equal to 0. Divide this one by 3 and we still get 0. Set the next one equal to 0. We're going to have to add 1 and divide by 3. Okay? And then for the last one, we're going to have to use the quadratic formula. So x equals negative of the b value plus and minus the square root of the b squared minus 4 times the a times the c all over 2 times the a. Okay, so I'm going to do some simplifying. Let me change colors because it's all starting to run together. All right, when I figure out my discriminant, let's see, we end up with negative 27. Okay, and so then I'm definitely going to have an I in my answer, but I also have to make a factor tree and see if I can take out any sets. And I can. Okay, and so we are going to, again, I'm running out of room, sorry about all this. All right, we're going to take out a 3 with an I because of the negative 27, and then we're going to leave a 3. And then you can see that that does not match this answer because I need to reduce. All right, negative 3, 3, and 18 all have a 3 in common. And so when I reduce, I get a 1 here. Technically, I get a 1 in the second one, but I don't have to write it because of all the other stuff. And then I get a 6 on the bottom. Okay? And so this started out as an x to the 4th problem, and I do, in fact, have 4 answers. All right, and then number 6, hopefully you felt like that one was a little bit easier. When you go to look for that GCF in the beginning, you actually, because it's already equal to 0, you can take out a 2x, and that leaves you with an x squared, minus 8x minus 20. And hopefully you notice that that's, that's a pretty normal trinomial because it's got just an x squared there. And so I do need to see if I'm going to need the quadratic formula or not. So I asked myself, okay, is there a pair that multiplies to be negative 20 and then adds to be negative 8? All right, and I don't know about you, but I got negative 10 and 2, which means this thing normal unfoils. All right, and so we put our x in the front of each, and then we need a minus 10 and a plus 2. And we're done with our factors. So we're going to set each factor equal to 0, and we're going to solve. So this one we divide by 2, and we're done. This one we add 10, and we're done. And this one we subtract 2, and we're done. Okay? All right, moving on. All right, check your answers to 7 and 8. Again, if you got them right, feel free to fast forward through the video. Otherwise, you will need to go through and look at the work with us. So in number 7, it's definitely not equal to 0. So that's the first step. So I'm going to subtract 1x squared. I'm just put it with the wrong thing. And I'm going to subtract 18, and it doesn't actually go with anything. All right. And so remember, when you put it all together on the same side, you want to put it in order from the highest exponent down to the lowest. So we're going to do x to the 4th first, negative 17x squared in the middle, and then the negative 18 or minus 18 at the end. And then it's a trinomial. It's not a normal trinomial, but it's very close because the first power is double the middle power, and then there's a constant. okay? So this, if it factors, you can factor it like other trinomials, like the one we did in the last problem. So I need to see, is there a pair that multiplies to be negative 18 and adds to be negative 17, okay? And that's going to be negative 18 and 1. So this is going to normal unfoil. The only difference is, instead of a single x in the front of each, we're going to put an x squared in the front of each. And then everything else is normal in terms of, doing the minus 18 and the plus 1. All right, so I do notice that I have squares, but I check to see if I can factor in more, and I cannot. Neither one of them are dots, and so I am going to have to set each one equal to 0 and then solve them with square roots. So add 18, square root both sides, make a factor tree, because we can take out a set of 3's. Remember, you need a plus and minus when you take a square root. We can take out a 3 and leave a 2. All right, and then for the next one, we're going to subtract 1. So we're taking the square root of a negative, so you're going to get an I. You still need a plus and minus, and the square root of 1 is 1, so we literally get 1i. You don't have to write the 1. Okay? All right, number 8 kind of looks like the last one where I have an x to the 4th and then an x squared in the middle. It is equal to 0. I have that constant at the end. So it's still a trinomial, right? It's still a trinomial, but I don't have a GCF this time. So this is one where you're going to have to see if the AC method will work. All right, and so I need to know if there's a pair that multiplies to be negative 36 and adds to be positive 35, right? And hopefully you got 36 and negative 1. So the AC method is going to work. So remember, that means you keep the first and the last terms the same, but the middle turns into your 2 over here. So I need a positive 36. We have to put an x squared with it so it matches the x squared in the middle, and then a minus 1x squared. Remember, you could switch up the order if you wanted to, but we should end up with the same stuff at the end. All right, so now we're going to factor by grouping. And let's see, I have a 4x squared in common, using an x squared plus 9. And the only way to get x squared plus 9 on the other side is to take out a negative 1. All right, and so then x squared plus 9 is one of my factors, and 4x squared minus 1 is the other factor. All right, and so then because I have squares, I actually do want to check to see if I have dots, which I do. So I'm going to take it one step further and unfoil the dots. Okay, and now we're ready to set each piece equal to 0 and solve. We're going to have to use square roots on the one with the square. When you square root a negative, remember you're going to get an I, but 9 is a perfect square, so you're going to get a 3i, plus and minus. All right, 2x plus 1, we're going to minus 1 and divide by 2. And so I have these out of order down here, but you still get, so it doesn't matter which order you put them in as long as you get all the individual answers. All right, and so again, that does represent 4 answers because plus and minus 3i is 2 answers, and then you've got your negative 1/2 and your positive 1/2. Okay, now I didn't make you go through and talk about whether these were real or complex, and if they're real, are they rational or irrational, but I hope that you can do that. All right, and then last but not least, number 9, again, check your answer. And again, if you feel comfortable with that answer, then you are done. Otherwise, you'll want to stay on for just another minute or 2. All right, so we need to make this thing equal to 0. But I notice that I'm not going to have any like terms when I subtract 24x and subtract 72. And I do want them in order in terms of highest power down to the lowest. You always want to put them in order. Okay, and so now because I notice that I have 4 terms, I can go straight to grouping. All right, because that's really the only way we know how to do anything with 4 terms. So I'm going to take out my GCF. And then on the other side, I notice that they're both negative, but what's left needs to be all positives. So I am going to take out a negative 24. And so x plus 3 is one of my factors. and x squared minus 24 is my other. It does have an x squared in it, but 24 is not a square, so it is not a dots. So I'm ready to set my pieces equal to 0. All right, the first one's easy, minus 3, and we're done. The second one, you're going to have to get x squared by itself and use square roots, which also requires that you simplify the radical by looking for pairs. All right, and so let's see, we're going to have a plus and a minus because it's a square root. You're going to have to take out a 2, but you're going to have to leave a 2 times 3. And so again, I didn't do them in the same order when I wrote down the answers for you, but as long as you have them all. Again, this was an x cubed problem, so we should be able to account for up to 3 solutions. So this is 1, and this is 2. All right, and that's it on homework 5.4. Okay, if there's anything you still don't understand, feel free to watch that section again, or hold your questions till the next class. Thanks so much.